David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today's video is on probability trees. Now, probability trees are a very powerful way to illustrate sample space. And they're really good because basically if you make a good tree for a situation, then you can use that tree to analyze any probability concerning that situation. So let's take a look. Here's our example. A bag contains 5 blue marbles and 2 green marbles. 2 marbles are selected with replacement. Now let's talk about what that means with replacement. It means that I'm going to draw 1 marble out, take a look at whether it's blue or green. I'm going to put it back, mix them up, and then draw another one. So when you see that word with replacement, it means whatever you've drawn goes back in. If you don't see replacement, then your second draw is going to have different probabilities because we've taken 1 out. Okay, so your first task, pause the video and draw a sample space diagram. This is that table or that grid. Okay, so here's my grid. I've got my first draw listed vertically and my second draw listed horizontally. Blue row, green row, and then the blue column and the green column. And then I've just got blues and greens in there for each possible outcome. Now you realize that there are 4 different outcomes for this. There's 2 blues, there's a green first, blue second, there's a blue first, green second, and then 2 greens. So that's our sample space. Now what I'd like you to do is calculate the probabilities for each one of these outcomes and come back. Okay, let's see how you did. So here are my 4 outcomes, blue, 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 green, green, blue, and green, green. I've put them in fraction form, they're probabilities. Now remember, these are independent events, so we're multiplying the probabilities of each event. So I just multiply my fractions straight across, and I got my probabilities for each possible combination of marbles. Now there's something you can do to check to make sure all this math is right. If you haven't already done that, pause the video and do that. So if you calculate all the probabilities for a situation, all those individual probabilities must add up to 1. And so indeed these do. I added these 4 fractions up, I get 49 out of 49, which is 1. So that's a nice convenient confirmation that I did all my math there in the correct way. Okay, so now we're going to illustrate that sample space with a probability tree instead of a grid. So I'm going to walk you through that very carefully. So first off, we make a branch for our first event, which is first draw. So I'm going to write that down here. That's first draw. So that's reaching into the bag and drawing a marble. So we have an outcome here that's blue, and we have a second outcome that's green. So this is our branch. We reach in, we have 2 outcomes. So if we get the blue, we're on this branch, and if we get the green, we're on that branch. So trees have branches. So do probability trees. Now I can write the odds right here. So blue is our 5 to 7, and our green is our 2 to 7. So now I have the start of my tree. Now the second draw, we're just going to make branches off of our first one. So we have blue and green here, and we have blue and green there. Okay? So this is the full probability tree for our situation. And we can put the odds here as well. 5 over 7, 2 over 7, and so on. And now, the thing about the tree is that we can put our total probabilities at the end of each set of branches. So here's the probability of blue, blue. That's going to be 5 over 7 times 5 over 7. So this one is 25 over 49. I want you to pause the video and finish that math and finish out the tree. All right, now let's use our tree to calculate some probabilities. Now the first one, what's the probability of getting a blue and a blue? We've done this before. It's just multiply the 2 blue branches, so that's 5, 7 times 5/7. So we know that one. That's 25 out of 49. It's just over 50%. Now let's look at a more tricky one. Probability of at least one blue. So take a look at your tree and figure out what that probability would be. All right, this brings out an important point with probability trees. When you're figuring out the probability of one path through the tree, you multiply along the branches. So just like we did before, blue is 5/7 times 5/7. That's 25 over 49. But when you have multiple pathways that satisfy your event, then you add those individual pathways together to get the overall probability. So let's take a look at this second one, at least one blue. There's three ways to get that. There's blue-blue, blue-green, and green-blue. So what I've done is I've taken these three probabilities, 25, 10, and 10, all over 49, added them together, and I have 45 over 49. Now there's a shorter way to get this one. Take a look and see if you can figure that out. Okay. So the shorter way is to realize there's only one probability that doesn't give you at least one blue, and that's this one, 4 over 49. So you can subtract that from 1 to get the probability of at least one blue. So that's another way to go. Okay, one more probability. Exactly one green. So not 0 greens and not 2 greens. Exactly one green. Pause the video and do that calculation. All right, so there's two ways to get that. There's blue-green and green-blue. So what I've done is I've taken these two probabilities and added them up here, 10 over 49 plus 10 over 49, to get 20 over 49 for the probability of exactly one green. One last calculation with this tree. Pause the video and find the probability that both colors will be the same. Okay, there's two pathways that get us the same color. There's the blue-blue path and the green-green path. So we just add the probabilities for each of those paths together and we get 29. Let's do a second example. So Bob is this guy that likes to do archery, another archery example for you. And his probability of hitting the target is 0.8 or 80%, okay? Now, Bob takes 2 shots. So he gets to shoot one and then he gets to shoot the other one. Now, first step, create the probability tree for that. So pause the video and do that. This is a little different because we don't have marbles in a bag. We just have a straight up mathematical probability. But it's the same idea. So pause the video, see how far you get. Okay, so here's my probability tree. My first set of branches are a hit and a miss. 0.8 for hit, 0.2 for miss. If it's 80% chance of hitting, then it's going to be 20% chance of missing because there's only 2 outcomes in this situation. And then we make a branch off the second shot. So first shot, second shot. So hit again, miss again, hit and miss. So if you haven't already done so, calculate your probabilities for the end of each of the 4 outcomes. Let's see how you did. The probability of 2 hits is 0.64 or 64%. Probability of hit miss or miss hit are the same. That's 0.16 or 16%. And the probability of 2 misses is 0.04 or 4%. All right, so we already calculated the basic probabilities for the 4 possible combinations: hit, 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 miss, miss, hit, and miss, miss. We did that. So now I've given you 3 slightly more complicated probabilities to calculate. What's the probability of exactly one miss, probability of at least one hit, and the probability of the second shot being a hit? So go ahead, pause the video, calculate those 3 probabilities, and come back. All right, let's see how you did. Exactly one miss. There's 2 combos that do that. They're each 16%, giving us a 32% chance of exactly one miss. The probability of at least one hit is 1 minus 2 misses. And 2 misses is 0.04. So at least one hit has a 0.96 or 96% chance of happening. The last one, the second shot, is a hit. There's 2 outcomes that do that. There's this one and this one. So that's 0.64 plus 0.16 is 0.18. Now, you can look at that one in a different way. We're just looking at the second shot. So what's the probability that that shot is a hit? That would be our original 0.8. For any shot, the probability is 0.8 that we get a hit. Let's do one more probability tree type situation. Now this one is a little bit tougher in the critical thinking category, so let's take a look at it. So here's our deal. We've got a tennis player, and let me give you a little background. In tennis, a player serves the ball to his opposing player, and they throw it up and they whack the ball really hard, and they try to get it in the boundary because that means the ball is in play, and the opposing player has to hit it back, and they go back and forth and have a volley, which results in a point for either the server or the responder. Now, the server gets 2 tries to get the serve in. And so the first time, they hit that ball as hard as they can, because if they don't get it in, it's okay. They don't lose the point. They get a second chance. Now, on the second chance, they're going to be much more cautious, not hit it quite so hard, just to be sure they get it in. So again, they have a chance of getting a point. If they miss on the first and second serve, then the opposing player gets a point. So that's the background you need to analyze this particular situation. So let's take a look at some probabilities. First off, if the player gets that first serve in, then they have a 0.75% chance of winning the point. So that's a 75% chance. And that makes sense because that first serve, they're going to hit it really, really hard, and it's going to be hard for the opposing player to return that serve. So they have a 75% chance of getting the point if that first serve goes in. If the first serve isn't in, then that means they only have a 45% chance of getting the point. Because the first serve was out, so then the second serve, they're not going to try quite as hard. They're going to just make sure they get it in. But then that means that the opposing player has a better chance to win their point. So those are the first 2 probabilities. First serve in, I can win the point 75% of the time. Second serve in, I can win the point 45% of the time. Now, to analyze this situation, we need 2 more probabilities. The probability that I get the first serve in is 3/5. The probability that I get the second serve in is 3/4. So you can see this is a little bit higher probability because I'm going to back off a little bit, not quite hit that so hard. So now I want you to draw a probability tree reflecting this situation. And I'm going to give you one hint before we start. The 2 events are first serve and second serve. So that's how you organize your tree. So go ahead and pause the video and give that a shot. I made the first 2 branches for you. We have first serve in, that's 3/5, and that leaves 2/5 for first serve out. So now think about that. Think about what comes next. All right, so now we can analyze the likelihood of getting a point. We know the first serve went in. So that means we have a game, we're going back and forth, somebody's going to win that point. And here's where that 0.75 probability comes into play. First serve in, 0.75% chance of getting the point. That leaves a 0.25 chance for getting no point. So this branch is analyzed. Okay, so we now know what the probability for this branch is in terms of getting a point. But there's another way to get the point, and that's on the second serve. So you're going to have to add that on this branch. This is first serve out. So go ahead and pause the video and make your branches that go out there. All right, let's take a look at this. So first serve went out. We're not dead yet. No point has been made because the server has a second chance. So here's that second chance, in and out. The second serve going in has a 3/4% probability. That came from right up here. Probability of second serve in is 3/4. That leaves 1/4 for the second serve going out. And notice here how out, that's no point for the server. They served both serves, they didn't go in the boundary, so the opposing player got that point. So, but the first serve out, second serve in, we have a chance to get a point. So now, if that's the case, the server getting a point has a 0.45% chance of getting their point and a 0.55 chance of not getting a point. So now we have a complete tree for this scenario. So let's review that. Getting a point is first serve in, point, or first serve out, second serve in, point. Okay, so now let's do some probability calculations. Okay, the first probability I want you to calculate is what is the probability that the server gets a point. So pause the video and do that. Let me give you a hint. What we do is we analyze the branches where the server gets the point. We figure out the probability of each branch, and then we add the branches together to get the total probability. So what I like to do when I'm analyzing my tree is I put stars at the end of the branches that I'm interested in. So here is in point, and then the other one is out in point. So now that you have those two branches, pause the video, calculate that probability, and come back. Let's see how you did. So here are my fractions. I just grabbed the fractions from the tree branches that yield the things I'm interested in. So I have these two times each other, and then those three for the second branch, because there's three probabilities to get to the end of that branch. I did my multiplication, got these two numbers, added them together. So the probability is 0.585, or 58.5%, that the server will get a point. Now we did conditional probability in our last lesson, so we're going to throw one of those problems in to this calculation. So check this out. What is the probability that the first went in given that we earned a point? So pause the video a little bit, think about that, figure out what you're going to need to do to calculate that. So I want to give you a prompt. Here is that probability expressed in terms of the formula we got with conditional probability. So it's the probability of the intersection of both events. So the intersection, what's the probability of getting the first in and the win? And then it's the probability of the total zone, which is getting a point, which is given that they got a point. So that's the math for that. That's the symbolic math. If you haven't already done so, pause the video and calculate that probability. Okay, so the probability of the intersection, getting the first one in, the first serve, and getting the point, that was this branch of the tree. We calculated that in the last example, so I'm just bringing that over. There's a 45% chance that they're going to get the first serve in and make a point. So that's the intersection, the and condition restrictive. Both have to be true over the probability that they got a point. So this is the given that probability that they had a point. So that's the bottom. And the probability that they got a point, we also calculated that on the last one. That was 0.585. So now we just divide this by that, got 0.769, which is 76.9%. So that means that given that I got a point as the server, there's a 76.9% chance that my first serve was in. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.